Hello, everyone. Welcome to week 2 of our course. And for this week, we are studying about water. Okay, so let me share with you my screen so that I can discuss to you the slides that I had already posted on Canvas for you. Okay, so let me further discuss with you. This is already discussed in your module, and I will still discuss this with you guys. Okay, so why is water so important? Why is it the most critical nutrient of all the nutrients that we are going to study for food chemistry this semester? Okay, so how much water does our body need? Our body is made up of about two-thirds or 60 to 70% of water, and three-fourths of water is found in our blood cells. All right. Fruits and vegetables are about 95% water, and meat is about 75% water, while us, the human beings, we are 60 to 70% of water. Okay, so even our brain must have 75% of water. Okay, so it is very important for us to have this amount of water. It is the it is the most important nutrient because it enables the nutrients to move towards our digestive tract. Okay, so it also removes waste products from our body. It is also a heat regulator. Okay, so water has a very high heat capacity. So for example, you are going out. Okay, so here in Canada it is winter, so when you go out, you do not freeze, okay? Because you are made up of water, and water does not enables us to have heat in our body. Okay, so although outside, if you are going to throw a glass of water, it will easily freeze because of the negative 25 degrees Celsius, but we will not easily freeze there because of the water that serves as heat regulator in our body. Okay, so but you must be very careful. Okay, you must bundle up. Okay, so water is needed in the body because it also acts as a diluter. So when we say diluter, it will dilute, okay, the food that we had partaken. Okay, so this will help prevent constipation. Okay, so some of us have problems in our bowel movement, so just drink plenty of water. So, speaking of that, drinking plenty of water, how much water is necessary? Okay, so they say 8 cups a day or 8 to 10 glasses a day of water will do. However, if we are active, we should increase our water intake. And in the Philippines, it is very hot. We must also increase our water intake in order to prevent heat stroke. Okay, so it is very advisable to take 2 to 3 liters of water a day. All right, so because it will help flush toxins in the body fat, it will help one feel full without the calories because water has 0 calories. So it is the most healthy beverage that we can drink. Okay, so if we do not drink enough water, we will be dehydrated. Okay, so what are the signs of the dehydration? We have there enumerated already. So we must prevent dehydration. And if we are dehydrated also, we lose some of the electrolytes in our body because the food that we eat do not separate into ions. Okay, because we lack water. Okay, water enables ions to separate. Okay, so with that, if we are dehydrated, we also lack ions, just like the potassium, magnesium, okay, chloride ions that are very vital to the functions of our body. So Again, water is the most critical nutrient for sustaining life. So make it a habit to really drink water, 2 to 3 liters a day. Okay. So again, water composes 75% of our brain. It regulates body temperature, makes up 83% of our blood, removes waste, removes toxins, prevents us from being constipated. Okay? And it also helps in the absorption of the nutrients in our body, and it also um, becomes lubricant for our joints. So that is how important water is. Now, more about the chemical structure of water. Okay, so water molecules are made up of two hydrogen and one oxygen atom. Okay, we already know from our previous chemistry subjects that hydrogen is positively charged and oxygen is negatively charged. Okay, so with that, water is a polar molecule. So when we say polar, it has the partially positive end and the partially negative end. The two hydrogen atoms make it partially positive, while the one hydrogen atom makes it partially negative. So with that, water molecules attract with each other, and they are bonded by hydrogen bonding. So that means this partially positive hydrogen bonds with the partially negative oxygen. Okay? So the two water molecules bond together. Okay? So here another water molecule, and this is another water molecule, the partially positive hydrogen atom is attracted to the partially negative oxygen atom. So they bond together by what we call as hydrogen bonding. Hydrogen bonding is one of the bonds in chemical bonds of chemistry. Okay, so water has unique properties. Of course, it has high boiling point due to its very high heat capacity. You boil water at 100 degrees Celsius. However, if you are on top of a mountain, the boiling point will be different because of the atmospheric pressure. Okay, the atmospheric pressure here, normal atmospheric pressure is 1 atmosphere, while at a higher altitude it is lower or lesser than 1 atmosphere. So that means at higher altitude, you can boil water at less than 100 degrees Celsius. But here, at normal temperature, no, at normal pressure, 1 atmosphere, you boil water at 100 degrees Celsius. Okay, so solid form is less dense than liquid form. That's why ice floats in water. Okay, because the solid form of water is less dense, or it has lesser density. The density of water, liquid water, is 1 gram per ml. Okay, and that depends or varies in the temperature. Okay, because that 1 gram per ml is at 25 degrees Celsius. Okay, but if we go different temperatures, it will just vary 0.998 or 0.99999, like that. Okay, so so much more about that. That is for purely chemistry if you're going to be very specific with the density of water. Okay, now water also has the properties cohesion and adhesion. We already learned that last week, the properties of matter. Cohesion is the attraction between like molecules, while adhesion is the attraction between unlike molecules. And water has both that properties. It also has capillary action. We also discussed this um last week for our properties of matter. It is the climbing action of liquid. Okay. So we also discuss mixtures. For mixtures, it could be homogeneous or heterogeneous, right? For homogeneous, we have solutions, and for heterogeneous, we have colloids and suspensions. Okay, so Water is known as the universal solvent. Why do we dub it as the universal solvent? Because it is polar, it can dissolve most of the solute. Okay, so when we say solute, it is the substance that will dissolve. Solvent, it is the substance that dissolves the solute. And the mixture of solute and solvent is called a solution. Okay, so water is the universal solvent again because it dissolves most types of solutes. Okay, so we already discussed suspensions. Suspensions wherein solid settles in liquid, that is a heterogeneous mixture. And with that, since water is polar, okay, polar liquids dissolve other polar liquids, but polar liquids will not mix with non-polar liquids. Example for that is oil and water. Oil and water never mix with each other because oil is non-polar while water is polar. So we call those substances that do not dissolve in water as hydrophobic. Okay, hydrophobic from the word phobia, it means it is water fearing. Okay, while hydrophilic, that means water loving. Substances that are attracted to water, substances that dissolve in water. All right. So we have also to determine the pH of the solution. So when we say pH, it is the power of hydrogen that tells us the acidity or basicity of our solution. Okay, so the higher the value of the pH is only at the range of 0 to 14. Okay, so 7 is the neutral pH. Okay, so that means it is neither basic nor acidic. Above pH 7 it is basic, and below pH 7 it is acidic. Okay, so for the basic pH, we have the hydroxide ions, and for the acidic pH, we have the hydronium ions, or the hydrogen plus or the OH minus. Okay, so that's it for the pH scale, and we also have buffers or weak acids or bases that can be used to balance out strong changes in pH. And our bodies use buffer chemicals to maintain a balanced pH. Because, say for example, our blood, if it becomes acidic, we have a disease called acidosis. And if our blood becomes basic rather, we have a disease called acidosis, alkalinosis. Okay, so when we say alkaline, that means basic. Okay, so our body maintains that one, the buffer chemicals, in order for our body to stay neutral at pH 7. Because if our blood will undergo alkalosis or acidosis, okay, death can be a consequence for that one. Okay, so this is our pH scale. For pH scale, our 7 is neutral, above 7 again is basic, and below 7 is acidic. Okay, so you will have exercises for this in your module. Okay, so what are our pH indicators? Of course, we have the litmus paper, we have the pH paper, and we can also use the cabbage juice that will give us the changes in color in order to tell whether a solution or a substance is acidic or basic. Okay, so water, um all foods rather contain at least some water. Okay, so in foods, there are two types of water: free water and bound water. So when we say free water, it is held inside cells and maintains the properties of free water and may be removed by pressure. However, for bound water, this is part of the molecule structure reduce mobility, and does not retain properties of free water. So you have the differences between the two for bound water and free water. And water activity, if there are more bound water, then there will be less water activity. Okay, so foods are more perishable if they have higher water activity. So, because microorganisms need water, okay? So, the more water there will be in food, the more moisture there will be in food, okay? Microorganisms feed on water. So, that's why the food spoils easily. Now, how are we going to preserve food? We can preserve food by drying, we can preserve food by freezing, and we can also preserve food by adding sugar or salt. Okay, so if you might notice, in our in the previous time, technology was not yet there. There was still no refrigerator. So what will happen is our ancestors used salt in order to preserve food. Okay, so say for example is the dried fish. Okay, they want to preserve the fish. So they sun dry the fish, they put salt in the fish. So we have now the bulad nowadays, which is very yummy. I miss eating that bulad. Okay, so with that, okay, food is being preserved, okay, by taking water from it. Okay, so we also have dried fruits. All right. So we also have for sugar, the jam. Okay, because we are taking the water quantity in order to lesser the amount of water activity for the preservation of our food. So the use of water in food preparation, as what we have said, it is a universal solvent. It is used for heat transfer and so on and so forth. Okay, so when we say hydrolysis reactions, that means when you are going to use water in order to separate, okay, some chemicals because they ionize. Okay, so again, that is the nature of water. It is a polar molecule. Oxygen is the partially negative side, and the two hydrogen atoms partially positive side, making it a polar molecule. Okay, so now there is what we also call as water hardness. Okay, so water hardness means there could be a lot of ions that are there in water that makes it hard. Okay, it doesn't mean hard that you cannot break it or soak, whatever. Okay, so as we all know, we have types of water. Okay, we have the mineral water, the purified water, the distilled water, the alkaline water that are available in our market. Okay, so when we say mineral water, of course, minerals are there. Okay, the spring water. For purified water, okay, the water is just being filtered. But for distilled water, that's the time that the ions are taken away from water, making it soft. Okay, so that's the reason why in chemistry laboratory you are going to use distilled water, always distilled water, because there are no ions that are there already. Okay, it is already soft, so the ions will not react with your chemicals. The ions will not react with what you are studying, so you must use the distilled water in the laboratory. And for the alkaline water, it has very very slight basicity in it. Okay, because we already know that our stomach is acidic because it secretes gastric acid, and gastric acid is around 0.3% hydrochloric acid. Okay, why is there a need for acid in our stomach? That is in order um to grind or to digest the food particles that we are eating. Okay, so some of us might have an acidic stomach, okay, because maybe we don't eat on time, maybe we eat more acidic food, okay? Just like drinking a lot of juice, drinking coffee, okay? Drinking tea, those are acidic, okay? Making our stomach even more acidic. So that's why we have the alkaline water. We also have the antacids that will be useful for that one, okay? So we have here our table also for hard water versus soft water. Okay, so the top water that comes from our faucet is hard water. And when you boil it, in time, your kettle will have scales around it. What are those scales? Kanang magputi-puti sa kilid. Okay, because those are the ions that um, that adhere to the scales. Okay, so the tap water that we have from our faucet is hard water. The distilled water, it has been taken away with ions, that is soft water. All right, so that's just all about water. And you are going to answer your module. Where am I going? Here. Sorry. And you're going to answer your module for water, determine which is acidic, which is basic, and you are also going to kung sa pagani mo sa inyo ang activity. Wait a minute. Okay. Okay, you are just going to determine which is acidic or which is basic or which is neutral. Well, when we say neutral, it is only water that is neutral. Mhm. And you're going to identify whether a substance is polar or non-polar. So we had discussed that already. When you say polar, it has the partially positive and partially negative, making it we have a positive pole and a negative pole. So that is polar, and water is a polar molecule. And non-polar, there is no negative and there is no positive pole. Okay, so it is not having the positive charge and the negative charge. Okay, but the charge has zero. The net charge will be zero for the molecule. Okay, so non-polar and polar substances do not mix with each other. Okay, only polar substances mix with each other. Okay, so say for example, alcohol and water. Alcohol is polar, water is polar, so they mix with each other. While oil is non-polar, water is polar, they do not mix with each other. Okay, so if you have more questions, kindly inbox me on Canvas. And you have the flexibility to work on your module. Okay, just be sure to start working on your module before Friday of each week so that you will be giving me your concerns, your questions with regards to our topic on our consultation period. Okay, so again, we will not meet on our scheduled class TDOA. This lecture recording is our TDOA. You may or may not go during our consultation hour, but I will be here on Google Meet for consultation hour Friday 10 to 11 a.m. Okay, if you have concerns, I'm just here online. If you have questions, I'm just an inbox away on Canvas. Thank you very much, and let me remind you, Module 2 is due February 27 midnight, and prelim exam will be open camera. Okay, thank you very much for coming to class, for watching this. Subscribe to this channel, subscribe to my other channel, The Other Side of Me. Bye, class.